They used to transmit all the data through copper wires. And it was pulses. Pulse, 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 really fast through copper wires. And it's kind of hard to get a lot of pulses through the same wire because they interfere with each other. And you lose a lot of the signal with distance. Well, somebody else had a better idea. They said, let's put the light through glass fibers. So, if you have a glass fiber and you shine light through it, the light can go through the fiber. But a bunch of it shoots out the walls of the fiber. And so, a fiber 10 feet long, you'd have a little bit of light at the end, but not very much. And somebody else said, well, you got to get just the right size of fiber. If it's too big, it might not work. If it's too little, it might not work. If you get one that's just the right size, the light, instead of shooting through the edges, will bounce inside. Boing, 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 boing. And it won't lose any energy as it hits the walls. Turns out, it worked. So we have fiber optic cables that can transmit light for miles. Well, he was out there goofing around with the minions, and they were being their usual bad selves. And he got really mad at him. And he grabbed one of them's baseball bat and started hitting him on the foot. Whack, whack, whack. And that made the minion really mad. The minion was trying to run away. And the minion looked at evil Mr. Fred and went, ah, like that. And laser beam shot out of his eyes and caught evil Mr. Fred's mustache on fire.
Yes!
And evil Mr. Fred, of course, did the ooh-ah dance and put his mustache on. And then he said, now we've got something. This is great. If I can get the minions mad, they'll use their laser beam eyes and shoot whatever I tell them to shoot. We want to find out if we can make the laser beam bend a little bit. And we also want to create a microscope out of the laser beam. A laser beam, when it goes through air, stays relatively small. When it's close to the board, it's that size. And as you get further and further and further and further away, it doesn't get much bigger in size. We want it to get big fast. If you shine the laser through a lens, it'll bend the light. That's called refraction. And any imperfections that are in the lens will show up on the board. We'll give one laser pin to each group of two and one lens to each group of two. First, you're going to shine it around, see what the laser does on various things in the room when I turn off the lights. And then, after you get that out of your system, you're going to put the lens on the end of it, and then we're going to give you some stuff. And you're going to put stuff in the light beam display. Some of the stuff that we have is a piece of screen door screen. And we have a box of old microscope slides. In the center, there's a little panel with something on it. Like one has a locust wing, one has a bee antenna, one has a butterfly scale. And you're going to try to make them big enough so that you can see them.
That kid can do anything. They're supposed to get a board out of there. I ate it and I was fine. They're fixing the guitar.
You have to look closely at the lines. There's a pattern between the lines that we want you to see. You probably didn't see perfectly black lines. If you look carefully, you would have seen shadows like waves bouncing off of walls. Inside the lines. These extra waves are called diffraction.
I saw that.
There's an antenna of a butterfly. There's a bee abdomen. Now, the objective is to make that, whatever's on the slide, look really big.
Mr. Mark, we found those.
Okay, make it as big as you can.
I see. Oh yeah, look at that.
I'm trying to make it big on the board. Oh, there's one.
I got it. Look at this, Mr.
That's the
Mac.
bee leg.